Hello and welcome to grade 11 chemistry. Today's learning goal is we're going to learn how to draw Bohr Rutherford diagrams and Lewis dot diagrams. So hold on to your seats because here it comes. So in order to be able to accomplish our task, we have to first understand what is an atom, what is it made of, and what does it have to do with drawing Bohr Rutherford's and Lewis dot diagrams. So to start, we have to know that an atom is made up of subatomic particles. These subatomic particles are either protons, electrons, or neutrons, okay? Um, so an atom, everything is made of atoms, okay? The whole world around you is made of atoms. And pretty much the only difference between different types of atoms is their size, okay? So a simple atom is made up of three things. It's made up of protons, neutrons, and electrons. I should really say all atoms are made of that. So, protons, excuse my messiness here, guys. I'm just getting used to this. Neutrons and electrons. Okay? So, protons, neutrons, and electrons. And really what we need to understand about them is where are they located? I'm going to write L to say where they're located. Okay? What is their charge? Okay? And what is their mass? So LCM, so location, charge, and mass. Protons are located in the nucleus. Neutrons are also located in the nucleus. And electrons are located in shells or on the outside of the atom. Now the charge of the protons is positive. We often say it's positive 1. So if you have 2 protons, that means it's positive 2, or 3 protons, it's positive 3. Neutrons are neutral, so they have no charge. And electrons have a negative charge. Okay? Now the mass of protons is said to be 1. Okay, we use something called AMU, which stands for atomic mass unit. Doesn't mean a whole lot, it doesn't mean anything yet to us, but we'll get to it later. A neutron also weighs 1 AMU. So if you have a proton and a neutron, the total mass will be 2 AMU. And so they just add up like that. Now electrons, this is a little bit of a lie. They essentially weigh nothing. So we don't say they weigh anything. So an important thing that we talk about is protons, well, they contribute to both mass, 1 AMU, and charge. Neutrons just contribute to mass, and electrons contribute just to charge because they have no mass. So if we wanted to look at a very simple atom, what we'd have is our nucleus, okay? And that is very, very small. It's basically, if the school was a atom, the nucleus would be a grain of sand, or even like a golf ball, maybe a little bit bigger than a grain of sand, a golf ball in the middle of the school. And in there you have your P's and N's, your protons and neutrons. And around it, so you have a positive charged nucleus. Okay, all the mass is in there because protons and neutrons contribute to the mass. Around it, what you would have, excuse me a second here, you would have electrons, okay? Your electrons would be in orbits, okay? So they'd be orbiting around this tiny, tiny little nucleus. So you have your tiny, tiny little nucleus that's positively charged. It's right in the middle, like right there, very, very small. And around it, you have these electrons. So again, just to quickly review, in the center, what you have is you have your positive charge in here in the center and all your mass, and around it, traveling at the speed of light, you have these electrons that are orbiting, and they're going extremely quickly. Okay, let's talk about how to draw Bohr Rutherford diagrams, for example, okay? We're going to start with the most simple Bohr Rutherford diagram. I'm going to have you guys do some of these in class. The most simple Bohr Rutherford diagram that you can do is the most simple atom. The most simple atom is hydrogen. When we look at hydrogen, it's got two numbers. The smaller number is referred to the atomic. Okay, this is the atomic number. The bigger number, and normally for hydrogen is exactly the same, but the bigger number is always the atomic mass. So you got your smaller number and your bigger number. Now the mass we remember from our atom comes from the protons plus the neutrons. The electrons don't contribute anything. And the atomic number just tells you the amount of protons. So you can see all of these different elements on the periodic table. And the most important number that we look at is this atomic number. And each atom, as it goes up, all we're doing is we're adding a proton. Okay? And that proton is changing the type of element it is. Okay, there's neutrons and electrons being added, but it's the proton that determines what type of atom it's going to be. So if we back up and we talk about hydrogen, hydrogen had two numbers, okay? The atomic number was 1, and the atomic mass number was 1. So to determine, to do Bohr Rutherford diagrams, what you have to do is you always have to determine the numbers of protons, electrons, and neutrons. Okay? Now, we know that the smaller number, in this case they're both the same. You'll notice that I kind of rounded the mass number, and you always have to do that. We'll explain why later. But the atomic number is actually the number of protons, so that's 1. Okay, and the atomic mass number, this number here was supposed to be bigger, was supposed to be P's plus N. Now we know that this equals 1. Okay, so right now we have 1 proton, and in order for this equation to work, we know that we must have 0 neutrons. Okay, so we know that in order to have a mass of 1, that means we only have 1 proton. Now the interesting thing here is as well is that protons are positive and electrons are negative. So whenever we draw Bohr Rutherfords, initially we draw a neutral atom. And a neutral atom has the same number of protons equals to electrons. So in this case we have 1 proton, we have 1 electron, just like that. So let's go ahead and draw this on the Bohr Rutherford diagram. To draw Bohr Rutherford, what you do is you start with your nucleus, and in the nucleus you have P's and N's, and this will represent our nucleus. And like we just determined, we know that we have 1 proton, and we have 0 neutrons. We also know we have shells around our atom, okay? And we know that we have 1 electron. So we take our electrons and we just put them like this. Okay, so we go 1 electron here. Our next electron in our first shell will actually go here. Okay, so next what we're going to do is we're going to draw the Bohr Rutherford for fluorine. Okay, this one's a little bit more of a complicated atom, and I wanted to just show it to you quickly. If we zoom in over here on fluorine, fluorine has 2 numbers. It had a 9 and an 18.99. So essentially, our atomic number now is going to be, which represents the number of protons, is going to be 9. Okay, and we round this all the time. The atomic mass number is 19. So here is our fluorine with the 9 and the 19. This is again my atomic number, which is representing my protons, and this is my atomic mass. So again, our atomic mass is protons plus neutrons, okay? And we know that's going to be equal to 19, okay? And currently we have 9 protons. So 9 plus the number of neutrons is going to be equal to 19. I'm not going to insult your algebra intelligence here, but that's going to be 10. So our atom, when we look at it, has 9 protons and 9 neutrons. So when we take, you can see I minimized that there, but we have 9 protons and we have 10 neutrons. So in our atom, we're going to have P's and N's, and our protons are 9, and our neutrons are 10. So we have to figure out how many electrons we have now, okay? So oftentimes we put the P's and the N's on in the middle, but we really should be just kind of keeping track of everything to the side as well. So we have P's, E's, and N's. That looks really messy. Give me a second there. So again, if you were listening before, we have 9 protons, and that means we have 9 plus charge. And we know the electrons don't weigh anything, but we know if we're going to draw a neutral atom, you have to have 9 electrons. Okay, so now we're going to place those electrons in shells around the atom. Let's place our electrons around the atom. So the first shell we know holds 2. I will explain why in a moment. And the next shell holds 8. So the first shell holds 2 E's, or electrons, with a negative charge. That's what that means. Second shell holds 8. The third shell, which we don't show here, also will hold 8. And you can do this on the periodic table. If we look at the periodic table, we can show all the Bohr Rutherfords up to calcium. And you'll learn in grade 12 why we stop at calcium, but we can only do Bohr Rutherfords up to calcium, and then it doesn't work anymore. But if we want to know, so we only really deal with 3 shells, okay? And the first shell is actually represented by the first sort of row here, okay, or period. We call this is why it's called the periodic table. This is the first period, okay? And in the first period, where I'm putting my pen here, there is 2 elements. So therefore there is 2 electrons that can be held in the first shell. The second shell, or second period, if you count with me, 1, 2, 3, 4, 5, 6, 7, 8. It can hold 8. And the third shell can hold 1, 2, 3, 4, 5, 6, 7, 8. And so that's how you can tell, always remember 288. And that's how I remember that it can hold 288. So let's place our electrons on our atom. So the first shell holds 2. So what you do is you get single electrons placed and then you pair up. Since the first shell holds 2, these guys get paired. And paired electrons, we're going to learn, are happy electrons. Second shell holds 8. So what we do is we start at north, and then we just go around it every corner. So east, south, west. So far, if you're counting with me, we know we replaced 2 there, 4 in this shell, so that's 6. I have to place 9. At this point, once my shell is half filled, then I pair. Okay, we do not pair any of these first 4. You only pair once the shell is half filled. A lot of students make that mistake. So now we're going to pair up. And if we take a look, I've taken care of every single one of my electrons. I've got 9 electrons, 9 protons. It's neutral. This 1 electron here we're going to learn is unhappy because that's actually on its own. Every other electron is in a pair. And we're going to learn that electrons, like people, like to be in pairs. Guys like girls. Electrons, well, not all guys like girls, but you know what I mean. Electrons like being in pairs, okay? So again, the most important thing that we need to remember is that we always half fill the shell, okay? Then we pair. Okay. All right, so what we're going to do next is show you how to do a Lewis dot diagram. Okay, when we look at our Bohr Rutherford again, before we do our Lewis dot diagram, you can see this outermost ring of electrons. Well, these are called valence electrons. And valence electrons are the outermost ring. They are the ones that are important. The inner ones are not important because they don't interact with the environment. Okay, paired electrons are stable. They relax each other. It's the bachelors that cause trouble. These pairs are stable, stable, stable. And this bachelor here, this lone electron causes trouble. Just like people, bachelors cause problems. It's true. So we have this bachelor here, and that's really what we're concerned with when we're chemists. So when we look at fluorine, all we have to do to draw the Lewis dot diagram, if you recall, we had 7 electrons in the outermost shell. So when we draw that during our Lewis dot diagram, we're just going to draw the outermost shell. So we start with our element symbol. So we don't draw protons and neutrons anymore. All we show is the element symbol, which is F for fluorine, and then we don't draw a shell. All we show is our 7 electrons that we have. And again, I like to draw them half fillet. And then we pair. And that is the Lewis dot diagram for fluorine. Okay? If you recall, for hydrogen, its outermost shell had 1 electron. So for hydrogen, all it would be is this. Hydrogen element symbol, 1 valence electron. Okay? Okay, that's the end of your first lesson. Thanks for listening. Hope this was useful in helping you learn chemistry. Look forward to an excellent semester with you this year.